In this tutorial, I'm going to show you how to graph a quadratic equation. We have y equals 2x squared minus 8x plus 7. And we've learned that different pieces of this equation tell us different things. For instance, this 2 tells us since it's positive that the parabola will open up. And since it's a 2, which is greater than 1, it would be a vertical stretch. The 7 tells us that it should intersect the y-axis at 7, so right up here at positive 7. This negative 8 comes into play when we're trying to figure out our axis of symmetry. So we learned that the axis of symmetry, it's a vertical line, so it's x equals, and it comes from negative b over 2a. So in this case, we would have x equals negative b, or the opposite of b, is negative 8, which is just positive 8, divided by twice a, and a is 2, so 2 times 2 is 4. So our axis of symmetry is at x equals 2. And I like to just kind of put a dashed line so I can see where the axis of symmetry is, and I know that that should actually divide my parabola directly in half. I could fold that parabola on that dashed line and it should line up with itself. So from here, now that we know the axis of symmetry, since this is going to mark that line of symmetry, that vertex of this equation should be on there. So since the vertex should be on here, that means the x-coordinate of the vertex should be 2. So I need to figure out what is the y-coordinate if I plug in 2. So if I plug in 2 up here, 2 squared is 4, times 2 is 8, minus 8 times 2, so minus 16 plus 7. So 8 minus 16 is negative 8 plus 7, that's going to be negative 1. So our vertex is going to be at the point 2, negative 1, and we're just going to mark that right here. And like I said, we know that this should be going up because it's a positive 2, but the question is, where does it go? It's going to be a vertical stretch, so it's going to be a little bit narrower than our parent function. But we can just use a table now that we have our vertex to figure out where other points are. So we know that 2 is our input value for our vertex, so I like to pick points kind of around that. So you could pick 1 and 0. So if I plug in 1, 1 squared is 1 times 2, that's going to be 2, minus 8 times 1, so minus 8, and then plus 7. So 2 minus 8 is negative 6, plus 7 is a 1. So I also have a point at 1, 1. And then we knew before that our y-intercept should be 7, and this is confirmed when we plug in 0 for x, because that would take away the 2x squared and the negative 8x term and leave you with 0, 7. So that's going to be right up here. Because this is a line of symmetry, that tells me that I should also have a point at 3, 1 and at 4, 7. And we could plug these in to actually confirm. So if I plugged in 3, 3 squared is 9, times 2 is 18, minus 3 times 8, so that's going to be minus 24, and plus 7. So 18 minus 24 is negative 6, plus 7, I do in fact get the 1. So you don't necessarily have to plug them in, but you have to really be sure that you are right when you plugged in the first set of points in order to confirm that the other set of points are correct. So now we just have to connect our points with a nice smooth line, which mine doesn't always look very smooth when I'm using this program, but you can see where it's supposed to be. You put arrows on the ends to let your reader know that yes, this continues, your domain was not restricted, so it's going to continue growing up. And that's how you graph a quadratic.